All right, the mirror shown is attached to the wall by an arm that can extend from the wall. In the figure, points P, Q, R, and S are the vertices of a parallelogram. This parallelogram is one of several that change shape as the mirror extends. Answer these questions. A. What happens to the measure of angle P as the measure of angle Q increases? B. What happens to QS, the segment, as angle Q decreases? And C. What happens to the overall distance between the mirror and the wall as angle Q decreases? Pause the video, write down your best answers. Feel free to compare with a neighbor. All right, today's lesson, using parallelograms in the coordinate plane. Example 1. Find the coordinates of the intersection of the diagonals of parallelogram LMNO with vertices at L14, M74, N60, and O00. Let's start by plotting the points. L is at 1 and 4, M is at 7 and 4, N is at 6 and 0, and O is at 0, 0, the origin. Let's connect our sides. And now we have our parallelogram LMNO. We would like to draw the diagonals. Take a ruler, straight edge, and connect the diagonals. We'll note here we can see the intersection. Remember from yesterday, the intersection is at the midpoint. We can find this graphically, or we could find the midpoint of the opposite vertices. That is, we can look at L and N and find the midpoint. 1 plus 6 is 7. 7 divided by 2 is 3.5. 4 plus 0 is 4. 4 divided by 2 is 2. If we go, we can check and verify. 1, 2, 3 and a half, and up 1, 2. So we can say that our intersection of the diagonals is located at 3.5, so 3.5, comma, 2. Now your turn to try. Find the coordinates of the intersection of the diagonals of parallelogram A, B, C, D, with vertices at 1, 0, B at 6, 0, C at 5, 3, and D at 0, 3. Start by plotting the points, draw the diagonals, and identify the intersection. Compare with a neighbor when you're done. Pause the video to give it a try. Example 2. 3 vertices of a parallelogram W, X, Y, Z are W, -1, -3, X, -3, 2, and Z, 4, -4. Find the coordinates of vertex Y. Let's start by plotting the points we know. W is at left 1, down 3. X is at left 3, up 2. Z is at right 4, down 4. And we don't know why. Now, we know the coordinates go in order. So we know that we have here W, and then we have X, and then we have Y, and then we have Z. So we know that Y is located here between X and Z. Now, we know that parallelograms have opposite sides congruent. If we look here between X and W, we can see that the space between X and W is right 2, down 1, 2, 3, 4, 5. Therefore, the space between Y and Z has to also have that right 2, down 1, 2, 3, 4, 5. So what we're going to do is we're going to go from Z and we're going to reverse the movement from Z to get to Y. So from W to X will be the same as Z to Y. So if I wanted to go from W to X, I would go up 5, left 2. So from Z, we'll go up 1, 2, 3, 4, 5, left 1, 2. And we get our missing point Y. We'll go ahead and connect them. And we see that we do, in fact, have a parallelogram. So our Y we see is located at 2, 1. And done. Now your turn to try. 3 vertices of parallelogram ABCD are A at 2, 4, B at 5, 2, and C at 3, -1. Find the coordinates of vertex D. Pause the video, give it a try. Compare your answer with a neighbor when you're done. Go ahead and get the practice assignment from the sub. Complete it, drop it in the basket when you're done.